Welcome to the tutorial Particle Effect Basics, the first tutorial in the Harmony Particle Effect video tutorial series. So in this tutorial, I'm going to give you a brief introduction into the particle effect systems that exist in Harmony. So particle effects are a huge time saver. Anytime you have to draw multiples of anything at a mass quantity, clearly it's going to take a lot of time, even if these animations are not hand-drawn. So when we think of particle systems, we often think of natural phenomena such as rain or grass or swarms of insects, but really particle effects can extend beyond that to include almost anything. They can be explosions, they can be confetti falling from the ceiling, they can be bouncing balls. Pretty much anything that you can think of, you can develop into your own custom particle effect system. So particle effects work pretty much in the same way as all the other effects in Harmony, except that they work within their own system. So you should think of each particle effect as its own group. So to begin, let's take a look at this particle system in the network view. I'm just going to zoom in a little bit. So you might notice something right away, and that's that this system is a lot more colorful than anything else you may have seen in the network view thus far. And that's because particle systems are color-coded. So not only are the modules color-coded, but so are their imports and their outports. So for example, this module happens to be a sort of turquoise green, and we see that this port in this purple module is also turquoise green. And similarly, the output of this module happens to be purple. So you can tell right away that these two modules belong, and it also gives you an indication when you're building your own system of what types of modules can connect into other types of modules. So this color coding, like anything else, is obviously customizable, and you would do this by going into your preferences. So if you're using Windows or Linux, you would go to Edit Preferences. However, if you're working on a Mac, you would go to Stage Preferences. So the Preferences panel opens, and you would have to navigate to the General tab and then click on the Edit Colors button. And then within the Colors window, you would click on the Particle tab. So here we can see that 6 different colors exist for various modules that are part of the particle effect systems. So let me go over what each color is, because each indicates a specific group. So I'm actually going to start with the second one here, Action. So the Action group is actually the largest group of modules that exist in the particle effects systems, and this is the module that allows you to decide how the particles are created in your system and how they move around in space. Unlike all the other modules in Harmony that are connected into a composite, actions are actually read from right to left instead of from left to right, and they hook into the system composite, which is the next category below. So a system composite obviously is designed to composite all the action modules, so these two module types work hand in hand. So the next group is the Baker module, and the Baker allows you to make decisions about the position, angle, number, etc. of the particles that are going to be emitted into your system. So I'm not sure why they have the region composite as its own group. It's not used that often, but it does happen to have its own group, which leads us into what a region is. So a region can be planar or 3D, and you can attach it to your system to be a place from where the particles are generated from. But not only can it be used for a defined area for the generation of particles, but it can also be used as bounce planes for where the particles can bounce off of, and it can also be used for an area in which the particles will disappear once they touch that region. So regions can be used for multiple purposes, and of course they can be plugged into a region composite if there are multiple regions. And obviously the composite will order these regions. So that would be the purpose of plugging in these regions into the composite. So the last group is the visualizer. So the visualizer is what assembles, flattens, and decides the render order of everything else in the system. And if you attach a peg to it, you can also move your system around using the visualizer. For me right now, I'm finding it a little confusing that the visualizer and the action groups happen to be very similar in color. So the one color I am going to change is the visualizer, and that's because, as I said, there are multiple actions that we'll be using. So let's leave it as its default color as this bright purple, where it'll be less confusing if we change the visualizer, as there's often only one or maybe two for a group. So I'll make it orange like this, since we don't have anything orange, sort of a reddish orange, which is good. And I'm going to say OK, and OK again. And now if we take a look at the particle visualizer in the network view, we can see that it's turned from purple to orange, as has the output for the particle baker. So if you're following along with these tutorials, you may want to change the color of your visualizer as well, just so that it becomes less confusing when we talk about that module. So before I go into the specifics of each of these individual modules, I wanted to show you one last thing, and those are the help notes. So let's go to the layer properties window for a moment and click on this down arrow to bring up another window. And let's scroll all the way down and select integrated help. And this brings up the integrated help window. So if you click on any particle effect module, help information appears in this window. So you can select, the sprite emitter, the information will change, the particle composite, once again the information will change. And let me actually select this help window and pull it out so that you can see what all the information looks like inside. So as you can see, the title of the module is listed at the top. You usually get a nice big colored picture showing you what the module does. Then below you get a description. If we continue to scroll down, you'll see that you actually get several diagrams showing you how to place this module in the network view, so which other modules can plug into it and which modules it can plug into. Then if we continue to scroll down, you'll see this module's layer properties, and below that is a detailed description of what all the functions in the layer properties do. And I believe this is the same information that you would find in the user guide. So I just wanted to let you know that those help notes were available to you if you ever had a question about what any of these particle effect modules were. So one other thing I have to bring up before I start going through these modules is I'd like to explain to you what a sprite is. You may have noticed that there's a sprite emitter here. So what a sprite is any drawing, image, so by image I mean bitmap image, or animated sequence that's usually an image sequence that can be plugged into the sprite emitter as the particle. So if you think about that's pretty powerful. So not only can you draw a dot and make that a particle, you could have an entire animated sequence of a character be a particle. So you can make multiples of, say, an army of toy soldiers, because you can have an animated walk cycle of a character be a particle, and then you can essentially replicate it and stagger it and do all sorts of things with it. So that's a pretty powerful thing to know. By default, if there's nothing plugged into the left port of the sprite emitter, so I don't know if you can tell from here, but it's blue, the same color that a drawing module would be. By default, we have dots that appear. So that's what we see here. It's just these kind of square pixelated dots. So anyway, let's start at the top with the planar region that's plugged into the sprite emitter. And because I have it selected, we see its layer properties here in the layer properties window. So to also get a better view of the planar region, I'm going to move to the perspective view, and I'm also going to go to the top menu and select View, Show, Controls. And you can use the keyboard shortcut Command F11 on Mac, and I believe it's just F11, or perhaps it's Control F11 on Windows or Linux. And so we see all of a sudden this blue rectangle appear. And if we turn our perspective view slightly, we can see that it's in fact very flat. It's not 3D. It's just a flat plane as advertised. So the first thing we can decide in the layer properties panel for the planar region module is its general shape. So right now it's set to rectangle, but if you click on the drop-down menu, you can see that several other shapes exist. There's the disc, there's the triangle, which I think is pretty small, you can't really see it. There's the line. Actually, let me zoom in here so we can actually see these shapes. there's the point, and there's an image which you would have to plug in an actual image. As you can see, there are 2 ports on the planar region, the green being for a peg, so you can move, animate, scale, rotate, change the position of the region, and there's a blue port which allows a drawing element to be attached. So if there's an image, then the particles would be, in this case, generated from that image. So I'm going to go back to the rectangle, and now we're actually in, I think, a bit too close. You can also determine the height and width here in the size fields. So let me change it maybe to something longer or more horizontal. Obviously, you can also use the transform tool in the camera view, to change the size if you want to do it more intuitively. And also, because there are functions available at the end of either of these 2 fields, we know that you can actually animate this region over time. So the next option is the radius, and the reason that it's grayed out here is because of the shape that we happen to have selected under the shape type. So if we change the shape from rectangle to disk, all of a sudden the minimum and maximum fields for the radius become enabled, and that's because they've now become applicable. So the last 3 options you have are changing the X and Y radius for 3 different points. So there's point 1, point 2, and point 3. And they are either available or unavailable depending on the shape type that's selected. So for example, if you choose triangle from the shape type, obviously these 3 points have now become enabled, and of course you can animate all of these points over time, and we know this because of these function buttons at the end of each field. So I'm going to put that back to rectangle. So now let's take a look at the next module, which is the sprite emitter. And this one has quite a few layer properties. In fact, there are quite a few, and there are 2 tabs worth of the layer properties, which lets you know a few things. You know that this is a very important module and that it's very powerful. So because it's really hard to see this, I'm actually going to click on the yellow box here to bring up the layer properties so that you can see everything in full. I might not go over everything, but I'll try to go over as many options as possible. But once again, I will refer you to the user guide because it really does have a detailed description of every single one of these options in this layer properties panel. So the sprite emitter, if I didn't already explain it before, is how you emit your particles. So how the particles are sprayed out or sprayed forward or projected. And of course we call it a sprite because, as I mentioned before, your sprite is the drawing or image of your particle. So if we look at the first category, the emission, we see that there are 3 options you can change. The first one being the trigger. So this uses the binary 0 and 1, 1 for on and 0 for off. So right now it's set to 1, which means that this module is functioning. So the number of particles is how many particles you want emitted per each frame. So right now we have 100 listed and we're on frame 1. So in this field here, or this rectangle rather, there are actually 100 particles. I'm not going to count it, but there are. And as we move the playhead across, 100 new particles are added per frame. So the probability of generating any particles is the probability of generating, in this case, 100 particles per frame. So if we change this to something like 50, then it's not necessarily generating 50 per frame, but there's now a 50% probability that it will generate 100 particles per frame. And what that does is it actually makes the generation more random, because if I put this back to 100, that means there's an absolute probability that 100 particles will be generated per frame. Because 100 is added each time, it's actually pretty mechanical looking. You can tell even though where the placement of the dots are random, it's filling up at an even rate, and that changing that probability makes it look a little bit more organic or a little bit more spontaneous. So the type generation strategy has to do with particle type 0 and particle type 1. Right now we actually don't have a sprite, but if we had a drawing layer attached to our sprite emitter here on the left hand side, and there were multiple drawings, so say there are 8 drawings, in that one drawing layer that we attach then to the sprite emitter. What you would do for particle type 0 is you would put the number of the first frame where those drawings start. So if they started on frame 1, then you would put frame 1 here. And if the 8th drawing on that layer then appeared on frame 8, you would then change this number to frame 8. Then this category up here would make more sense. So sequentially assign type number. So that way when it starts generating those particles, it'll go in order 1, 2, 3, 4, 5, 6, 7, 8 as it generates them per frame. If you say randomly assign type number, then it'll mix up those 8 drawings to generate them randomly, basically. And this will become more clear to you as I go through a few examples. Specifically, when we use the rain example, you'll see what I mean about having a couple drawings, or the grass example, there are a couple drawings, and you'll see what I mean. So the aging is something that's quite important. So when you assign an age to a particle, you're basically giving it a lifespan. And if you can track somebody's timeline, so their lifespan, that means you can assign certain attributes or animate certain attributes at certain times. For example, in a human lifespan, maybe at around 2 you start talking, but around 40 you start getting gray hair. So you can assign specific physical characteristics to things if you know at what age they're at. You know their timing. And so this is the same principle here for the age of a particle. So in the age at birth field, a different start frame number can be entered. This means that a particle can start with a different drawing than the drawing that you have on frame 1. And if these drawings are sequential, then it's like it's starting its birth at a different age. So the age at birth standard deviation allows for some randomization of the age of birth. So if you have a 5-frame cycle, for example, that starts on frame 1, but you want the particles to be of a random type, then you may want to set the age at birth to 3 with a standard deviation of 2. So what this means is that the particles were randomly born at any frame between 1 and 5. And that's because if you think about it, a standard deviation means how far you can deviate from an assigned value. Our value is 3, and if you can deviate by 2, that's both plus and minus 2. So plus 2 from 3 is 5, and minus 2 from 3 is 1. So the entire advanced section I'm not going to touch until we get to an advanced particle system. So I will talk about it, but it won't be for another few videos. So let's quickly look at the rendering tab. Okay, I don't know if we can see all of it here because it's quite long. There we go. So the first thing we have is the sprite selection. And once again, the sprite is your drawing, image, or animated sequence. So right now, like I said, it's just rendering dots, or these pixelated squares that are supposed to be dots. However, if we had a sprite connected to the left port of our sprite emitter, then we'd be able to choose one of the other options from the rendering strategy drop-down list, such as use frame number, use particle type, use age. Underneath these 3 options, number, particle type, and age, there's a second option, and they usually go something like use frame number as index in selector, use particle type as index and selector, or use age as index and selector. So you might be wondering what the selector is, and in fact it is the second option under the rendering strategy. So this lets us know that you have to use one of those 3 options in conjunction with a sprite and with this selector here. Basically what it means in plain English is that you can attach a function to the age of the sprite. So instead of just using the age as it is with no function connected, so it's not animatable, you would be able to now attach a function, and that's all that means. So let's just go back to rendering dots. So if you are once again using a sprite and you're using either frame number or particle type, so the type is what we just talked about, type 0 being the first drawing, type 1 being the last drawing of a sequence that exists on your sprite. Anyway, so if you have that selected and your particle type runs out after frame 5, then you won't see anything in the camera view after frame 5. So it's often good to cycle if you're going to use particle type or frame number. And you can select from either having a normal cycle, so it'll just cycle from the first frame to the last frame where there are drawings and then cycle back again, or you can cycle back and forth. So for example, if you have 5 drawings, it'll go from 1 to 5, then from 5 back down to 1, then from 1 to 5, and then from 5 back down to 1. So that's the order it would cycle those drawings. And you can also specify the number of drawings in a cycle. So for example, this relates a little bit back to the types from the generation tab. If you have 8 drawings on your sprite layer, you might want to only cycle the first 5, even though you indicated on the other side that there are 8 types. So you can put that value in this field. So I'm always going to go back to our defaults. So transformation, so this lets us know that these are some of the things that we can animate over time. So size over age, so this is a good one. As your particles age, because we've given them an age, you can change the size. You can make them either bigger or smaller, and once again, you can attach a function to that. So directional scale allows you to let the scaling process occur in the direction of movement. And then you can also change the directional scale exponent factor to change how quickly the scaling occurs in the proper direction. So align with direction is also a good one to have checked off. Depending on what your sprite is, direction might not matter. If it's a circle, it probably doesn't matter. However, for example, if it's a figure in profile where its nose and its face is pointing a specific way, needs to point a specific way, then align with direction is very important because it would look silly moving backwards, for example. And we are going to see an example of this in one of the later tutorials. So axis to align. So you can choose positive or negative X or Y, and of course it's taking in the X or Y axis that belongs to the drawing plane of the sprite. And this has to do with the grid, the 12-field grid that exists on this invisible or potential drawing layer. So you can also decide to flip the x-axis to match direction. So if your particles change direction throughout their lifespan or throughout your scene's animation, you can always have them flip to either match the x or the y-axis or both. This allows also for the rotation of particles, and to keep volume allows the height to squash or stretch along with the width if these things change while the particle is moving. And all these things are pretty simple to experiment with as soon as you set up your own particle system. So we can also change the color of our particle system over time. So the first and default setting that you have under the color strategy dropdown is use drawing color. So a lot of the times when you create a sprite, you want to keep the original colors of that drawing. Then you would leave this setting at its default. However, you can also map the RGB based on the age, or the RGBA, which means the alpha, along with the colors based on the age. You can apply opacity based on age, which if you think about it means that you can make your particles or your sprite progressively invisible, so it might fade out near the end of its lifespan. So not only can you map the RGB based on age, but you can also base it on frame, as well as the RGBA, so that alpha again with the frame, or just the alpha, or like just the opacity with the frame. So you may have noticed so far, you often have the choice between the frame number, the particle type, or the age. So clearly these are important factors to think about when you're going to animate some of these options. So this allows with a double click for you to select your RGB colors and your alpha if you're adding a function to them, if you've selected one of these map options. And then here at the bottom under compositing, we have a lot of options about blurring. The first one is just the general blur. So you can have no blur, directional blur based on age. Once again, we have the age and frame. We also have camera distance as a factor, and you can either have low quality, high quality, or directional blur. So you have many options to choose from here. So blur intensity you can change. Obviously a larger number would mean the blur would be more intense, where a smaller number it would be a very subtle blur. The fall off rate is the distance where the blur fades from the edge of the image. So the value range is between 0 and 1. 0 causes the blur to fade out slowly, so distributing the blur evenly from the edge of the drawing to the farthest edge of the blur, whereas a fall-off rate of 1 causes the blur to fade out quickly so that the blur is heaviest at the edge of the drawing. So the blend mode is actually quite fun. If you're familiar with Photoshop or even with After Effects, many compositing softwares also have these types of blend modes for different layers. So they're pretty well known. Multiply, screen, light and darken, difference, add, subtract, overlay, hard light. All these options exist in most design programs, so you can actually add them to your particle effects, which is pretty cool. As well as you can also choose their intensity. So for me, I almost think of intensity in terms of opacity, if you're thinking in terms of Photoshop. So even if you add an effect, if you make it less opaque, generally it's applied less intensely. So that's another way of looking at the blend intensity. And as you may have noticed, a few of these options are also animatable. I just realized that I didn't change this back to renders dot, and that's why we don't see anything here in the camera view. Okay, so the sprite emitter was probably the most involved module that I had to talk about, or the most detailed module that I had to talk about in terms of its layer properties. I'm going to continue on with describing the 4 remaining modules, but rest assured that their layer properties are a lot simpler than what we just experienced with the sprite emitter. So let's look at the move particles. And we can see here that we only have a few options. So the 2 major decisions that are decided in the move particles module is whether the particles will move or not, and whether they will age or not. So you might ask, well, why would you not want to move your particles? Well, you have some types of particle systems, such as grass, where movement is not necessary. But other times you have particle systems, such as rain, where obviously movement is essential. So at the top here, we have the trigger once again, so 1 being enabled and 0 being disabled. And obviously we have a trigger so that you can animate that option of turning this on and off. So here you can age the particles, but it's good to know that if you have the move position and the move angle already selected, then your particles will age anyway. Because if you see, I can't even age the particles. This option is disabled, but that's because they're aging anyway. It's already implied with these 2 types of movements enabled. So if you want to age your particles but not move them, then you would uncheck both of these. The age particle option becomes enabled, and then you can select that option. So the interesting thing about the move particle module is that 2 of its options exist in the baker, that being aging and moving. The reason that the move particle exists is because sometimes you need to perform multiple actions together in a certain order here, and the baker, as you see, is placed further down the system. If you have the aging turned on in both the move particle and in the baker, as we'll see, your particles will age twice as fast per frame. So be aware of that and make sure that if you have the aging selected in one, you don't have it selected in the other unless you're doing it intentionally. So I'm going to put it back to move position and move angle. So I think these are pretty obvious to understand. If you want to move the position, you would check move position. If you want the movement to have the ability to rotate, you would also check move angle. The last 2, make particles follow each other. You would enable that if you have a particle system similar to a string of beads moving like a snake across the plane. So that in that case, you don't want your particles to be dispersed randomly. You really do want them to follow each other. And the following intensity, if you have this option checked off, allows you to increase the strength of attraction between that string of particles. So I'm going to uncheck that and leave this as is. So then if we go to the particle system composite, we see it's as easy as enabling and disabling. And of course, all the actions, so all these purple modules that define the behavior of your particle system are plugged into the particle system composite, and that's its primary function. So from the particle system composite, we have the particle baker. So like I said, there's a few interesting things you can do in the baker, as well as age and move position. You can also add a seed, and the seed adds randomness to your particle system. And you'll see that this will come in handy if you ever want to copy your particle system so that it appears a second time in your scene, and you don't want them to look like 2 identical copies of the same system. If you add a seed to one of the 2, it'll give the appearance that the systems are a little bit different. So the simulation quality allows you to choose the quality of what you see here in the camera view. You can choose between normal, high, or very high. Obviously, the higher or the better quality that you choose the slower the system will be produced. So sometimes if your particles are not super detailed, you might not need anything beyond normal to have it look quite good in the camera view. So the number of pre-roll frames you can change here. What pre-roll frames does, it allows you to start your particle effect partway through its cycle. So a good example would be that if you didn't add pre-roll frames to a rain sequence, then as soon as your scene starts, the rain would slowly start to come in. However, if you added a few pre-roll frames, you could have it already be raining at the start of your sequence. So you can basically use this to shift over the timing of the start of your particle system. So the maximum number of particles you could indicate here, and this is so you can add a cap to the number of particles that are produced. As we go across, or as we drag the playhead across, we get to a place where the particles stop. Actually, I think we don't. I think we'd have to go actually to frame 100, because 100 times 100 is 10,000. So I think after 100, yeah, you can see for these last 3 frames, nothing is being produced. And once again, that depends on what you want. If you want it to go into infinity, you don't have to put a value here. And if you do want it to stop at a certain time, obviously this would be the place to cap that number of particles. So here's the place in the Baker where you can decide if you want to age the particles. And once again, I said this works in conjunction with the move particles, so you have to be aware of what is checked off or not checked off between the two if you have both in your system. The reason that we have these options in the Baker as well is because sometimes we don't have a move particles module in our system. So the Baker allows for us to have movement in our system without those action modules. And as well, it allows us to have the movement occur after everything has been read through the particle system composite. And we'll take a look at that in greater detail in one of the upcoming examples. So once again, we see the same options we saw in the move particles. You can move position and you can also move angle. So once again, move position is to move position, and to move angle is to allow subtle rotations in your particle system. So the last module we have to look at here is the particle visualizer, and this is the one whose color I changed. So the purpose of the particle visualizer is actually to flatten your entire system into a single plane. And if you notice here, there are 2 green ports on either side, which lets us know that you can plug a peg into either side. But this is pretty unusual for an effects module. Normally, if you have the ability to add 2 pegs, both of these green ports would be on the left side. The reason that they're separated like this is to let you know that they function slightly differently. If you plug a peg into the left side, you're able to move the entire system. However, if you plug a peg into the right side, what you're really dealing with is the depth, so the movement along the z-axis. And obviously this can come in handy when you have a second copy of your particle system. You may want to have 2 Bakers and 2 visualizers, and you can move one visualizer backwards in space so that it sits behind, whereas the other particle system might sit in front. So if we look at the layer properties for the visualizer, we see that you can force render as dots. And obviously this is a good option if you would like to run a simulation or a test of your particle system without it being bogged down by extraneous details. For example, if your actual particle is something quite detailed, it will take a longer time to render. If you really just want to run a test to look at the movement, you could always force to render as dots, and that way it'll be a lot faster. So rendering order. There are several rendering orders that you can choose, and this determines where the newer particles that are generated are placed. So back to front would put the newer particles in front. Front to back would put the newer particles in the back. Oldest to youngest would obviously put the youngest particles in front, and youngest to oldest would put the youngest particles in the back. Ascending types, so once again this has to do with the types that we've assigned on our sprite, so the actual numbers of the drawings. So this would put the types that are newer or have a larger number in front, and descending would put types that have a larger number in the back. And the last option we have is fix output alpha, and this has to do with the blending properties that we saw in the sprite emitter. If you remember, we had the option of adding all those effects such as multiply, screen, etc. So some of those effects, those blending modes, have an alpha channel that's necessary. So if you don't have the fixed output alpha selected, then that blending mode will actually have some pretty weird results once it's been rendered. So be aware that you would need this check mark, and it's check mark by default anyway. So that's it for the tutorial, Particle Effect Basics. Stay tuned for the next tutorial, Particle Effect Modules and Templates, Part 1.